Okay, this is it, CPGO, last section of the year. I know this is not numbered correctly at the top. I do apologize for that. I forgot to change it from last year. This should actually say 12.7, not 12.5. I'm going to go ahead and fix that right now. So this is it, 12.7, glide reflections and tessellations. Okay, so what exactly are we looking at here? So first of all, what is a glide reflection? A glide reflection is a composite transformation. So what does that mean? That means it's more than one transformation. And it's a composite transformation that is a translation or a slide or a shift, followed by a flip or a reflection using a line that's parallel to the direction of the translation. So the order of the glide and reflection doesn't matter, meaning you can reflect first and then slide, or you can slide and then reflect. You can do it in either way, either order. It doesn't matter. You're going to get the same image from the pre-image in the beginning. So for example, I have a triangle ABC. I have a glide, which represents my first, this is going to be a translation. And then, so this is transformation number one, and then transformation number two would be my reflection, where it would flip over that reflecting line. Same thing with like these footprints here that look kind of creepy, but it is what it is. So for this one, it's going to actually go the opposite direction. So this one, to get from foot number one to foot number two, I am going to first reflect over this line, and then I'm going to slide it up to get the second footprint. And then to get from the second footprint from the third to the third, I'm going to reflect it. So it's going to reflect directly over to here, but then I have to slide it up. Okay, so this is called a glide reflection. So it's a slide and then a flip. Okay, you can also do these glide reflections on figures in the coordinate plane by just doing a combination of a translation and a reflection. We've done both of these, we're just putting them together in one. So for example, if I have a translation that maps x comma y to x minus 9 comma y, that means I am going to be taking every x coordinate in my pre-image and I'm shifting it left 9 spaces. The y is going to stay the same. Once I've done that, then I'm going to go ahead and reflect it over y equals 1. So we're going to do these in pieces. Our first thing we're going to do is we're going to shift A, B, C, D, E, F to the left 9 spaces. So I'm going to do that translation now. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Here is B prime. Okay, so B prime. I'm going to take A, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's A prime. You can do these in any order you want. It does not matter. Okay, here's F prime. Here's E prime. 1, 2, 3. So here's D prime. Here's C prime right here. And you're going to want to make sure that you connect the dots so that you can see that your entire shape has had the glide part of the glide reflection. So there you go. This whole entire thing went this way 9 spaces because of the x minus 9. Okay, every x value moved to the left. Then we're going to reflect over the line y equals 1. So here's y equals 1 right here. There's your y equals 1 line. I'm going to reflect over that. So you're going to take every one of these points, count directly perpendicularly to that green highlighted line, and then you're going to count that many on the other side. So I'm going to do exactly that. You might want to fast forward through this if you want to. You don't want to listen to me talk about it because you know what you're doing. Please go ahead and do that. 1, 2, 3, 4, 1, 2, 3, 4. So here's B double prime. Let's see, this is C double prime, and this is D double prime. And I think I got everybody. Connect your dots, make sure that you are connecting them in the proper order. Okay, so that doesn't get messed up. And there you go. There is your second piece. So you have your glide, which was our purple movement, our shift, and then we're reflected using what we did in green. Okay, same idea for the second one, except for this time I'm subtracting 6 from y. So we are going to slide this thing. In this case, this y minus 6 means I'm sliding down 6 spaces. I'm going to take my entire figure and shift it down 6. Then I'm going to reflect over the line x equals 2. Okay, so take each point in your original image, your pre-image, excuse me, to make your first image as a slide down 6. Okay, so 1, 2, 3, 4, 6. Here's D prime. Here's E prime. This is F prime. So let's see. Here's A prime. B boop bop. Here's B prime. And here, nope, wrong spot. That's not what I wanted to do either. There we go. Here is C prime. So I'm going to go ahead and connect my dots, make sure that I connect them correctly, make sure the right dots get connected by a line segment. So I have shifted each one of these down 6 units because of the y minus 6. Okay, the x didn't change, so I didn't shift it left or right. I just went down for this one. Then it's telling me reflect over the line x equals 2. So the line x equals 2 lives right here. So I'm going to do exactly what I did in my last example. I'm just going to flip it sideways instead of up or down. So I'm going to flip f prime over to get f double prime. I'm going to do the same to E. Okay, and D as well. Oh, I should have, whoops. I'm going to go and head do 1, 2, 3 for C double prime. I know this is super boring. I will not at all be offended if you are fast forwarding through my explanation of this. I get it. It kind of messes with your own thinking. So if you need to either literally shut me up or fast forward through this, I respect it. It's probably the right move. Okay, so there you go. I've glide reflected this thing. I slid down 6 as my glide or my translation, and then my reflection was flipped it right on over. Okay, again, it doesn't matter what order you do this. If I would have reflected that direction first and then slid that down, I would have got the same image. Okay, you could do it either way. Okay. The last thing we need to discuss is called a tessellation. Okay, so a tessellation, L-A-T-I-O-N. MC Escher in the back of my room is known for his tessellated images. So if you're in class right now listening to this, just look at the backboard. And you can see many, many pieces of artwork from MC Escher that does tons with translations with tessellations. But a tessellation is a tiling or a repetitive pattern of the similar or same figures that completely covers a plane without any overlapping or gapping. Okay, since it covers the plane completely, entirely, the tessellation will then continue in all directions infinitely forever and ever. Okay, tessellations are created using a translation, so a shift. It can be a rotation. It can be a glide reflection. So any of those 3 options will give you, if you choose the right shape, will give you a completely covered piece of paper or screen. So we're going to assume that color doesn't matter in this thing. What we're really looking for is just the shape. Okay, so of these, we got 6 pictures here. We're going to decide, is it a translation, is it a rotation, or is it a glide reflection? Okay, so the very first one here, this is a great one. I love this one because it's kind of, some of us can see both. You can see the image in white and also black. This one gets a little confusing, but if you all see what looks like a cat with wings facing to the left, what I want you to look at is also a cat with wings that I'm outlining terribly that faces the opposite direction. So clearly there's a reflection going on here, right? Because it's like you would spin this image kind of right here on the front feet It spins around to create the opposite color, and it also is gliding. So if I'm taking the green highlighted black cat, I slide it to the right and I reflect it, and then I move it up, that turns into a white one. Or I just reflect it along that line and shift it up and turn it white. This is a glide reflection, okay? Because it's a reflection because it's facing, notice the cats or whatever this animal is facing opposite directions. That's a dead giveaway that it's a reflection, right? And it's like copied and pasted like it's being slid across the paper. So that's a glide reflection, okay? Oh my goodness, this one here is crazy. I'm gonna highlight these white flying fish. And if you take a look at them, do you notice how all their tails kind of, it's almost like somebody pinned the tail on these fish right there, and you can kind of spin them around. And it also overlaps with the red, like the red does the same thing. This is 100% a rotation, okay? If it was a translation, all of the fish would be facing in the same direction, okay? They are not. And there's clearly a point of like a fulcrum in which you would spin, like the center of a spinner, right? In this case, it kind of nails down the corner of their back fins or their tail, okay? The next one, this one's interesting. You all, I think, maybe can see like the beige colored dudes on horses. Well, there's also brown dudes on horses facing the opposite direction, dead giveaway for reflection. And it does totally look like they've been copied and pasted going down the line. So this, again, is another glide reflection. Okay, so it's shifting to the right, but it's also kind of swiveling on that vertical axis. So if I kind of, actually, I don't think that, let me see if I can find the right spot. It's like right through the top of the hat, I believe is what it looks like if I flip it around that way. Okay, all right. Next one, I got some lizards up in here. They're all facing different directions, so I can tell you right now, this is not a glide reflection, this is not a translation. If it was a translation, everything would be facing the same direction. So as I look at this, this is very similar to the fish one earlier. I have these two black lizards that are like nose to nose. The white ones are nose to nose, and it looks like they're just like spinning around in circles. So this is a rotation. Okay. The next one, I have beige horses and red horses. And what I want you to notice on this one, if I kind of like pinch in just on one row of horses and I ignore all of this stuff, this is just a straight up translation horizontally. This tan horse translated to the right become the red horse, and then it just keeps going. So that image just keeps kind of copying and pasting next to each other a whole way down the line, just the colors change. This is just a regular old translation. We're not flipping. The horses are all pointing to the left. They're not flipped upside down or anything like that. Okay, this next one's a little bit tricky, but what I want you to try to do is just focus on the fish. So if you just focus on the fish, you can see that each fish translates diagonally. You can go diagonally up or diagonally down, it doesn't really matter. All of the fish are facing the same way, so it's not a rotation, right? It's either a translation or a glide reflection. Well, the fish aren't flipped upside down. Let's check out the geese. Okay, or birds or ducks or whatever they are. If you look at these, whether you go take the pattern up and to the left or down and to the right, it doesn't matter. Nothing is being flipped. There's no reflection going on. This is just a straight up translation. It's just being copied, shifted, pasted. So that is a straight translation. You did it, Geo. That's it. You're done. That's the last unit for the entire whole course. All of it, you're done. You just need to study up on the review for this, take the test, be ready to study for the final, and grab a review pack, get ready for that final exam. Thank you so much. It's been a great year. I appreciate your time and attention, and you know where to find me if you have any questions.